Welcome back to another Advanced Game Maker Studio tutorial, and this time I'm gonna do a Patreon request. So as usual, patrons get the full stuff, so the project and all the files, but for free. For the other ones, I'm gonna show you how to do a laser bullet, because this is what this is, and it has some quirks to that, and I'll go into that. So for example, if you want a quick fix, for example, you're just shooting in 4 directions, then I have a very quick and dirty answer for that. But if you are doing diagonal, then this will become definitely more complicated. So stay tuned for those 2 solutions. This is OneUp Indie. I am the developer of the indie game Clunky Souls and a programmer / pixel artist. So if you're new here and you want more, consider subscribing to my channel, because I upload every day a video, and share my stuff if you can, because this is how I could actually grow at some point. So let's get right into the good stuff, because what we can actually do, and this is pretty easy, just for example, what we could do, make one sprite which looks like this. So this is one thingy here, then make it an object, and then let's uncomment all that stuff and do something like this. This we can actually kill. Alarm, okay. So what we can actually do is just spawn one of those, and this is working for 4 directions. And why do I say that? So for example, let's let's start it, because this doesn't work now. Go away. So let's start again. So what I'm just basically doing is like, hey, am I releasing my mouse button? Then I create this bullet, and then it flies in different kind of directions. For example, I made a little collision, and for example, once we are colliding, then we are hitting the enemy. But for example, once you are seeing this, you're thinking, wait a minute, this laser is not hitting my enemy here. Well, there are some interesting things to that. For example, if you are doing this in 4 directions, no problem. So once again, what are we doing? We are basically checking for a mouse button, and if we press, we create this laser, this dummy, and then store it into a variable. I call it laser bullet 2. You can call it whatever you like, so var bullet, and then we give the direction where to fly to. We store that into the direction fly variable. So for example, what is this doing? This is just checking between 2 points. This is the point of origin, so the X and Y of our player, and then the second point is the mouse, and what this thing is returning is an angle. So what is this angle? Can we basically just pass into this laser dummy, so this one blob thing, and we can give it the direction, and we can give it to the image angle, because the direction is just good for you, so it flies in a specific direction. The angle is so it rotates to this specific angle. So this is important as well. So, and then of course the image needs to be something like this. It needs to point to the right, so it has in the end the correct rotation. And then of course you give it some speed, and then bam, it flies. But now you're thinking, wait a minute, so why was it hitting? And here we come to the more interesting part, because let's say for example you want to debug and say, hey, let's draw a rectangle besides drawing yourself. This is the laser beam, the single one, and then we just draw a rectangle at the B box, and B box is just the bounding box points, which are 4. So for example, as you can see now, we have a red thing around it. When you're seeing this, so the rectangle is basically around it, so those bounding boxes are part of this rectangle, and this is where we have definitely our problem. So let's go into Photoshop so I can actually show it better. So let's say you're having this thing here, let's copy paste it, and let's say for example you rotated it, and then you're thinking, okay, I want my bounding box points to be somewhere. So here we have it here, and here. Of course it could be a little bit lower, doesn't really matter. And now you're thinking, okay, then it would be something like this, but it's not. It will be something like, let's need to delete them now. It would be something like this, bam, bam, bam. Why is that? Because this is a rectangle and therefore it has 90-degree angles. And then, for example, if you are rotating the whole thing, then you're stretching it, then you get a box like this. And this box is basically, even though maybe here there are no actual collisions, at least for you, logically, but there still are, because this is the rectangle and this is used for the collision. So this is a thing we cannot use, and this is a little bit tricky. So how can we circumvent that? Well, one way is to make lines, and for example make a collision line here, make a collision line here, and make a collision line here. Of course you can have more if you like, and then pretty much cover most of the area where you can actually have a collision with an enemy or whatever. And this is the tricky part. So for example, if you were just looking for a quick fix, so in those 4 directions, no problem, as you can see, doesn't skew too much, then you won't be having with some, well, wonky hitboxes, and therefore it is not a problem. But this solution is of course only valid for things, and this thing is pretty static. Of course we can upgrade it a little bit so it appears. Let's say, for example, what we can do, this is what I uncomment, so we can kick this out and this out. We want it a little bit to expand, and well, what we do in our step event, let's go back. I'm just saying, hey, expand my Y scale, because my Y scale at the start is 0, so it's basically invisible. Then we're making it a little bit bigger. Then of course we want to clamp it between itself, the Y scale, between 0, because this is the start value and this is the max, and then of course you can set it to 1. And then we set an alarm at 50, so under a second it will stop. And then we have this expand variable which is saying true. Then it's a later point it will say nope, you're pretty much gone, that's it. And of course we want to at that point say, hey, go to the max value if it hasn't reached it already. We can do that again, and now it will pop in nicely. Of course you can change the values, as you can see now. Cool, looks definitely better because it's appearing. Of course I made it quite slow, so you can change the values concerning the popping up, so how much you're basically adding to it, so to the Y scale. I do it very slightly, but for example lasers are quite instant, so you would put in higher values. The same for the speed, this is just for you, so you can actually see all that stuff. So now this would be the easy fix. Now we come to the more complicated part, because here we come to lots of problems, because now we need to circumvent, first of all, how to stretch that thing. For example, here you have that thing, but for example once you stretch it, doesn't look too good, as you can see. So what you do normally for lasers, you have 3 parts: the start part, the end part, and this thing, which is just basically 1 pixel. Then you just stretch it depending what kind of need you have, and then you pop in this at the end and pop this at the start. And here we need to get some values, and this is where it becomes a little bit more complicated. So let's go back in here, kill the easy solution for 4 directions, and make another one which I just called Object Laser Bullet Show. Call it whatever you like, doesn't really matter. And here I have the same code, so basically just passing in a speed. Of course, if it's a laser, put in the really higher values, because this is just for showing, so you actually see it on the screen. Then direction and angle. And here this is the same thing. So first of all, we again take the angle which we need to fly to, and then pass it to the direction and the, so basically our movement and our angle is already set, so there's no need for that. Of course you can later on do some optional stuff. I'm gonna go into a few seconds, and here we go into the thing, because there are lots of things there. So first of all, what do we need? First of all, we need the 3 parts which we're gonna draw, and then this is how I do it. I just say SPR laser, this is the thing, So this is just one stripe. I have different kind of colors, so you can actually customize it in the project here. And for example, you can set it up. And then we have the start thing. So this is the cap on the left thing here. This is the end part. So once again, I assign them to some variables, because what I want to do is put them in here. And for example, say draw sprite at the start, then the thing which I'm going to expand, and then the end point. And here we run into some issues, because let's kill that here. We can, for example, do something like this. Say, all right, no problem. I just have see the code nicely. For example, I do the start and the laser, and the laser, I just give it 8 pixels to the right. Then it will look alright, because they have the same image angle. For example, once we started, you will see something which is definitely not good. So for example, here on the right side, you see, this looks pretty decent. So what is the issue? Yeah. Maybe let's zoom in a little bit so you can actually see it. Yeah, it doesn't look too good. It definitely doesn't look too good, because the start part is not there where it should be. So we need to calculate it. Therefore, this solution doesn't work. We have to do it this way. First of all, we have a start value of x and y. So for the first sprite, which is just the starting thing here, no problem. But then we need to calculate the x and y to be. And how can we actually do that? Well, not too difficult. We just have to check them and get them by length via x and length via y. So for example, we go in here, check out what is actually happening. So first of all, you have here a start point where this, definitely don't know what the hell that is, doesn't really matter. So where this kid with yellow beat up eyes is, because I don't know why would anybody have violet yellow eyes. Never mind that. Okay, just completely confused by this picture. So this is our start point, and we want to get this second point. How can we actually get that? By adding length via y and length via x, and then with a specific direction, which is just an angle. And then we get the second point, which was which one we needed, because, for example, we rotate this guy, and well, we need now a point here and a point here, and these points are kind of important to get. So maybe let's put it in here, make a new layer. So first of all, the first part here, the cappy, no problem. This point we get, but we need the second point, which is a little bit off to the side. Therefore, we need length via x and y to distinguish the next point. Go for another color. Let's go for a nice green. So basically, we need a green here and a green there, because we need 2 points. First of all, a little bit more into the laser. Then the end point of the laser, which is just these 2 points here. And then the third point, which we need, go for a different color. One you can actually see. So this, and then we need the last point, which is this one. Therefore, I have a calculation which just calculates first of all for the middle part, which is being expanded, and then the end point, which is being expanded. And there I just do a length via function to return the point which we actually need. So the x point and the y point. And then you see, okay, why is there 8? The image angle, I guess you could understand, because this is the angle in which direction which we are moving to. But 8, this is just basically for the sprite, because it has a size of 15 by 39. Why are these numbers uneven? Because we need a definite middle point. This is quite important, because let's say your sprite is, let's say, 16 by 40, which I had in the start. And then you have no absolute middle point, and this could get into some weird glitching, because it cannot decide, okay, which point is more important, then it doesn't look clean like you see on the screen. So just keep in mind that therefore those things need to be uneven. So you have definitely a middle point, and then those 8 are 8 points to the right and 8 points to the left. And for example, from this middle point here, you go 8 to the or 7. I just put in 8 points to the right, theoretically at least. And therefore we just say, hey, 8 points away on the X and the Y, so we get those points. And the same we do for this. So for example, we go again with 8, but then because this is our endpoint, this little cap, we put in a scale, and this is the scaling of the image, X scaling of this part. Hope I didn't lose you already, because this is quite theoretical. So here, this has a scale now. So this is, for example, because it's just 1 pixel, and then I expand it the way I want, and therefore it is dynamic. Then I say, hey, expand it to, yes, I expanded even to 100, and then +7, because once again, the end cap is centered in the middle again, and then I need not this point, but this point. So you understand the code now, and therefore I need to get those two points. And for example, once we started, then you will see that in our drawing everything works correctly, or at least it should. Let's see why this is not working. Fail. Okay, not sure. Because it starts with 0. My bad. Yeah, so let's... No. So, what was the thing? Basically, what I'm just doing, it at the start expands. So, I have the scale while and scale, and these variables are put in to this middle part. So this at the start is a 0, so scale y is being used for all of them. So the y scale is just, well, we're doing something like this, it's 0, then we expand to the point that we do for all 3 parts, and therefore I have it stored in one variable, and at the start we just expand it. So this is the same thing which we did at this dummy thing here, but come on, I also expand the scale. So at the start this thing is quite small, and then, well, it expands definitely quite a lot, and therefore this part is being pushed to the right, because, well, it's being calculated with the scale. The scale is just the thing, the X scaling of the middle part, so it's dynamic. And then, well, once again, I just expand this one quite rapidly, so 10 plus 10 all the time. Of course, you can do it even faster because lasers are quite fast. This is just for you, so you can actually see the result in the end. And then, therefore, well, this is just basically the drawing. But now you don't have nothing which is for you maybe valuable, because this is just a drawing, and then it doesn't do anything. Now maybe you want to have some collisions, and therefore we go once again into the thing I showed you, because our collisions need to be with some points. So we need this point. Okay, terrible color for that. Once again, this point and this point. So we have our first middle, how can I call it? Our middle collision line, then a collision line like here. Okay, once again, completely terrible color. My bad, sorry. And then we have a collision line here, and then a collision line here. Then, well, this is a little bit more expensive, but therefore it actually does work. And this is actually what I do. And once again, I need to calculate all those points. So therefore, in this laser, there are lots of variables, lots of things which are being calculated at the start and basically during the runtime. And what you're seeing now, 3 lines, so the orange ones are on the outside. Of course, you can have a few in the middle, so you can have more collisions if you like. For example, once we are hitting the enemy very, very closely, for example, you can see it does work. Why is it disappearing? Because, well, I put in the very start, at the very end, just hits, and for that I have 5. So if we are having 5 collisions, destroy, and then it's gone. Of course, you could do that instantly, but nah. So once again, for example, if I need those specific points, which I just showed you, so these guys here, I need again to calculate them. How can I do that? I just once again have some variables which are called calculate and x middle. So this is the middle line of calculation. This is the top line, which were the orange ones. This is the red one, orange, orange. And then I just start with the x position at the start because I need to update it, and then plus the length there and our scale, because where my collision is basically, it is just, once again, let's copy this guy here. My collision will be just on the part where we have this thing here. So those caps are not counting into it. So I just wanted to keep it as clean and simple as possible. And once we calculate those, well, first of all, I can draw them. So once again, you see, okay, draw a line. This one is the red one. And then we just pass in those values because we need 2 points. So this is our start point, the x and y, and then to the calculated middle point, calculated top point, calculated bottom point. And these points are these 3 here. So at the end, that we can actually use in a collision. So we are not finished here. I know this tutorial is a little dry and theoretical, but I didn't see an easy way how to check it. So once again, we go for a variable, then say collision line with x and y, and then to the point, because this is a line, we need 2 points again. So start point and then the calculated 2 points, then the target to hit. This is just for me a start variable. Here we go. And then we just go for a parent or a regular enemy object, doesn't matter because you need actually one. And then we calculate it. And for example, if it's not returning no one, and I put in a little invincibility in there so you cannot permanently hit it. So then I just say, okay, you cannot hit it all the time, and then set it invisible, and then there has just a timer in there. You don't really need to know that. So for example, if you look into the project, here we see there's a timer in there, and bam. And then the last part, once again, and this is I know a little bit complicated, then I just put in some random values to create an object hit. An object hit is this just popping up of these things. Not too terribly interesting in my point. This is just so it appears a little bit random on the object which we are hitting. So we're just giving it random range. You can completely forget that. This is just some nuance, so it looks better. Then the last thing, we just subtract the hits, and once, for example, we reach in the end 0, we kill it, and then, well, this is how it works. Of course, it has some quirks, because, for example, if we go, let's say, here, no problem, you can see those lines are quite good. But for example, if you go diagonal, this one line looks a little bit off. Then you need to calculate once again those points. Didn't want to do that because, well, it serves its purpose. Of course, it is not the best solution. For example, here I would need to calculate once again and create new variables and create new length here. So we are just at those starting points. But nah, didn't want to do that. So therefore, I just skipped this part. But now you understand that this thing is definitely not as easy as it seems. So hopefully you could understand that. So once again, just to iterate it, so the laser, which we are doing once we flip it, is consisting of 3 parts. Therefore, we need to calculate lots of parts. First of all, for drawing, we need this point, which is x and y. Oh, come on, go on top, please. X and y. Then we need this point and this point to create and calculate this expanding part, which is pushing this one and this point. And all these 3 points are all the time calculated. The first one is not, because this is an x and y, and this is automatically updated. Then later on, what we do, we need to calculate lots of other points. For example, we need to get for the collision this point and this point for the middle collision. So for this collision middle line, and then we need this point and this point for the top collision, and this point for the bottom collision. And they will get a little bit, well, depending how hard the image angle is, a little bit moved aside. So for example, this one something like this, and this one, and this one a little bit something like this. But this is minor, so it should be not a really big issue. So this is how you do the collision. Then once you do the collision, you do your code, and depending how many hits you have, bam, you can kill it. And then the last thing is the image Y scale, because we just make it pop up and then we just do something like this, 0, and then bam, go into 1 or whatever value you want to have. You can expand it into infinity if you like, but this is how it works. Hopefully it wasn't too difficult. I know this is quite dry, but this is the only way how you actually can do those well, collisions and laser bullets in Game Maker Studio. That was pretty much it for today, and I hope I didn't miss anything. Nope. So that was pretty much it for today. Have a good one. One up indie.